part A, it says that the car is travelling on a level racing track. Okay, so I've got a horizontal sort of track here, and I've labelled the horizontal forces. So we've got the tractive force, okay, the force that's created by the engine pushing the vehicle forward. We've got a resistance of 540 newtons, okay, that's what's given to us in the question. And it says then find the power of the engine when the car is travelling at a constant speed of 60 meters per second. Now, what you should pick up on is that key, sort of those keywords there, constant speed, because of course at constant speed, the car is no longer accelerating. Okay, so at constant speed, the speed is staying the same, so we can say acceleration is 0. So that's kind of important, isn't it? Because when we apply Newton's second law, okay, of course we know the resultant force is equal to mass times acceleration, but in this case, because the acceleration is 0, the resultant force will equal to 0, yeah, which means that the tractive force will equal to 540, okay, or we can say the resultant force is tractive force take away 540 equals to 0, okay, because the acceleration is 0, so the resultant force leads to then having the tractive force to equal to 540. What you can do then, because we know the tractive force and we know the speed, we can use the formula then connecting power to tractive force. So power is tractive force times velocity. So we know that the tractive force is 540. We know the speed is 60. So we can then get the power from there. If we do that, we get 32,400 watts. Okay, or you can write it as 32.4 kilowatts if you want. Okay, right, so in part B then, the engine working at, like 32.4 kilowatts, which is what we just worked out in part A, and the resistance to motion unchanged. The car ascends a hill inclined at an angle alpha, okay, where sine alpha is 1/16. Find the acceleration of the car when its velocity is 15. Okay, so I sketched this earlier. So it's going up a hill inclined at that angle alpha there. There's the tractive force, okay, pushing the car up the hill. It's got a resistance of 540 because that hasn't changed. But of course, what you need to appreciate, when you're going up a hill, the weight is still sort of directed downwards, vertically downwards. So we now need to consider the component of the weight, okay, in the perpendicular direction to the inclined plane, but most importantly parallel to the inclined plane. If you remember, if we've got angle alpha there, this will also be angle alpha here, okay, and then you can resolve then. So with the angle here, containing the angle is cos, so we're going to have 800g cos alpha here, okay, and then of course the opposite of the angle then will be this sort of side there, this direction here, which is parallel, yeah, with opposite the angle there, so that'll be 800g sine alpha. Okay, so what we can do then is apply Newton's second law, okay, in the direction of the inclined plane, because that's the direction it's moving in. So we've got tractive force pushing it forward. Take away then the resistance, which is 540, but also take away the weight component, because the weight component is pulling it back, isn't it? When you go up a hill, you feel your weight pulling you back, and that's the component here. So 800g sine alpha. That will equal to then the mass, which is 800 times the acceleration. Okay, well, so we've got that now in Newton's second law. Okay, let's go back then to the power formula. Okay, so don't forget now, power is tractive force times velocity. Well, we know the power in this case is 32.4 kilowatts, so 32,400. Tractive force, we don't know, but we know the velocity is 15. Okay, so from here now, connecting these, we can work out what tractive force is. So tractive force will equal to 32,400 divided by 15. And if we work that out, we get 2,160 newtons. Okay, so what I can do now is plug that back into this one. So if we call this equation 1, plug my tractive force in there. Sine alpha is 1/16, and I can work out my acceleration. So let's just do that. So we have tractive force 2,160, take away 540, take away then 800 times 9.8, the value of g there. Sine alpha will be 1/16, equals to then 800a. Okay, so if you work this out here and do a bit of manipulation, take the 800 over and divide, you end up having, well, all of this side works out to be 1130, and then of course take the 800 over, so you get 1130, divide by 800, which gives you an acceleration of 1.4125 meters per second squared.